Good evening, everyone. Welcome to that webinar, very important webinar of fundamentals of cable pulling. And this is very special webinar where a special guest from America, Mr. Charles, is going to present. Before I invite him for that presentation, I would like to say a few words, a few background about the importance of cable. In the present era, the power system growth highly depends on the network laid for the power cables, because it has become difficult to find the right of way for the utility. Apart from that, when we talk about the aesthetic look, we talk about the right of way, we have to lay transmission system in a crowded place. We have only one option left, that is a cable. Unlike transmission lines, these are not exposed to air or atmosphere. There are very low chances of dangerous like cyclones, typhoons. Apart from that, when we talk about the electromagnetic compacts, EMC issues, these are comparatively less and these are not hazard to the wildlife. Last but not the least, we have switched over to GIS. When we talk about the GIS, the only option left out is the cable. Now, I would like to give a brief introduction about how the cables are laid in Indian scenario. There are four methods are there. The cables can be laid directly in the ground by direct digging. That can be drawn in the ducts pipe, SD pipe, or it may be trenchless technology. It may be laid in the racks in the air. Racks inside cable tunnel is the another option in the substations. When we talk about the quality of any cable, there are three things. One is the specification, second is the manufacturing, third is the laying and installation. And out of three category I have mentioned, the important part is the proper installations and laying methods plays very vital role, because incorrect installation techniques may lead to failure of your cable. There are some mechanical forces, tensions, sidewall bearing pressures. We have to do starting and stopping of cable pulling. We have to take care of total curvatures, low radius bands. We have to keep in mind the change in the elevations. Here comes the role of proper lubrication, because that lubrication we use reduce the frictions, that take care of your coefficient of friction, that take care of the sidewall pressures and tension that is going to explain by the presenter. It makes your installation faster. You can go with the larger distances. There will be very less splices. And now I'm coming to the available codes related to the pulling of cable. In Indian scenario, we have only one IS 1255, and sometimes we use IEEE 525 also. The section 2 of that IS deal with guidelines for the cable laying and installation. And there is one clause 6.9.2 that talk about the lubrication on the outer sheet, and it allows use of petroleum jelly or graphite grease. Now time to give introduction about the today's presenter. Today webinar is the fundamentals of cable pulling, and this is supported by the American Polywater Corporation, and it is being hosted by Mr. Charles Coles. He's the Vice President of Global Business Development. He is responsible for development of markets in regions outside of North America, Europe, and the Middle East. Major regions of focus of Mr. Coles includes Latin America, Australia, New Zealand, and India. He has been with Polymer for 18 years, and the beautiful part is that he uses his knowledge of effective installation practice and optimal designs of underground cable system to help minimize project cost and maximize system performance for the network stakeholder. Now, without wasting much time, I would like to hand over to Mr. Charlie, sir. Please, stage is yours to start your presentation. Welcome, sir.
Thank you very much, Dr. Rajesh. And thank you to all the attendees. I I hope that you will find the information that I'm going to be presenting over the next few minutes interesting and informative. And I just wanted to give you a little bit of background on Polywater, the company that I work for. We're an employee-owned company that was established or founded by a couple of chemical engineers from 3M Company in Minnesota. And we've developed a number of different products that can be used in the installation, maintenance, and protection of underground cable systems. We have operations, or we sell into over 80 countries around the world. And we've designated India as a very, very important strategic market for us. And we're doing a number of things to grow our presence there. So I welcome the opportunity to talk to you about some of these products and how they might help you in underground installation. So can you show the presentation?
Yes.
Yes.
Yeah.
Full screen? Yeah, we could see it, but could you make it full screen? Is it full screen?
1 minute. I'm just trying again.
Just
Okay.
go to slideshow and start from the beginning. Go to the top menu, slideshow, and go to the beginning.
Yeah. So can you see now?
Yeah, but
I can
we
see
cannot
it, but
the
I
full
don't want
screen.
I want the full screen. You're
Slideshow
showing
mode.
the, in the
I hope
menu
you have
bar,
shared
go
the-
to slideshow. There you go. Thank you very much. Sorry about that, everybody. Well, I've changed the title a little bit from Fundas of Cable Installation because I wanted to really focus this presentation on cable installation, underground cable installation in duct. The doctor mentioned a number of different techniques, but this is the one where I think is coming into fashion, more popularity, you're seeing more and more installations underground in duct, and there are a number of reasons for that. So this presentation will focus on underground installation in duct, and we'll look at different ways of how underground cable is being installed, and go into some of the details in terms of some of the best practices to be using. So let's look at different ways that underground cable is installed. Click, if you would, please. So if we start out with the first click, we've got this general category of underground cable installations, but there are variations of these different techniques that are used. So if you go to the next click, basically there's two major forms of installing cable underground in duct. That's through a trench and through HDD. horizontal directional drilling. Click. So from an open trench, you can direct bury. That doesn't involve duct, nor does reverse bore cable. You're boring using HDD technology, and then once you get to the end, you're attaching the cable to the HDD bore and pulling that back through. So that's not going through duct either. So let's go to the next click here. And where we do see duct, we're laying duct into a trench and then covering that duct up. And then the cable could be installed in that duct at a later time. It doesn't have to be done right away. The same is true for HDD, where we're reverse boring. Instead of pulling the cable back through in the reverse direction, we're pulling a duct back through and back through to the beginning of the bore. And then at a later time, we can install cable into those ducts. So one more click here. So this we call, when we're installing cable into a duct, we're calling that cable pulling as opposed to cable laying. We would be laying the duct in the case of a trench, but not the cable itself. So I think that one of the terms that I hear a lot in India is cable laying, and that defines, from what I understand, both cable laying in an open trench as well as cable pulling through a duct. So I'm going to differentiate those terms by using the term cable pulling when it's inside of it, when the cable is being installed into a duct. Next slide, please. Let's take a look at reasons why people are using, why they install in duct versus an open direct buried trench, or or the cable being installed or in contact with dirt, mud, water through a reverse bore HDD technique. First of all, when cable is installed in duct, there's a lot of protection of the cable inside the duct. There's no direct contact with water or dirt, reduces cable damage risk from digging and drilling, which happens a lot, especially in urban areas. There are also instances where, again, in urban areas where you've got different networks being placed in proximity to other networks. Those could be fiber optic networks or other electrical networks. And a good way of kind of keeping things separate is by using ducts and protecting them from exposure to other networks. There are safety concerns as well. Open trench is a hazard. You have to open the trench, and you have to keep that trench open until cables are laid. This is difficult when, let's say, cable delivery has been delayed and the trench has already been opened up. You've got pedestrian traffic that might be in danger if they fall into the trench. So there are some safety concerns. As I mentioned before, when using duct, you open up the trench, you lay the duct, you cover up the trench and the duct, and that protects any passersby. It also mitigates cable theft, which is a problem in a number of countries that I work in. I'm not so sure about India, but by using duct and protecting it that way, you can reduce cable theft. There are also lifetime O&M cost considerations that are important. They tend to be lower for duct installed cables, easier access to faults, easier expansion of networks if required. You can install empty ducts for future expansion, wherein a open trench, you would have to dig up that trench to install new cable that is direct bearing, not in duct. And then there are time to repair savings as well by installing cable into duct. We'll go to the next slide, please. There are statistics out there that greater than 90% of premature cable failures are due to incorrect installation techniques. And in the case of duct installed cable, those are mechanical forces such as tension and sidewall bearing pressure. And these forces are could be very, very high during installation. So we want to protect the cable to avoid these premature cable failures that might not appear for 3, 4, 5 years after the installation using incorrect techniques. Mechanical forces could also be very, very high due to starting and stopping cable pulling. I've seen that a lot in India, and we want to avoid that, because to get that cable, once the cable has been stopped, to get that cable moving again after stopping, you have to exert a lot of force on that, and that can damage the cable. Also, total curvature and low radius bends can cause a rapid buildup of tension and sidewall bearing pressure. So that's another thing that we have to take a look at, especially low radius bend. If your radius is too low, you can create a lot of sidewall bearing pressure, which is detrimental to the performance of the cable. And then, as the doctor mentioned, elevation changes are also going to increase your mechanical forces, your tension on the cable, because you're pulling up against gravity if that elevation changes from a low spot to a higher spot. So those are some of the reasons that we want to take care in terms of how we install cable into duct. So we'll go to the next slide. So here are some examples of what excess tension can do, or incorrect installation processes. We mentioned the tension on the cable can cause the cable to abrade, as you see in the bottom photo, and your pulling line could also cause problems with the duct itself by burning through if not lubricated. Again, stopping installation before installation is complete, it's going to increase that tension, as I talked about before. Lack of proving the duct. Proving the duct means that you need to put some type of missile through the duct before you actually start pulling the cable, to make sure that any debris or water or breaks in the duct itself will not impact the installation of the cable and create a lot of damage if we do decide to install the cable without into a damaged duct. Then there's an inappropriate design of the duct route. We've got some software that I'll talk about later that could be used to optimize the design of the duct route to minimize any of these damages. And then poor splicing and termination is also a cause of damage. And that's not so much an issue of cable installation, but that I just wanted to mention that because it is important. So if you can reduce the number of splices on a cable, then you're reducing the risk of that. And with proper installation techniques and practices, you can actually reduce the number of splices as well as the number of manholes. And again, we'll talk about that a little later. We'll go to the next slide. I just wanted to make a quick example, or show you a quick example of a problem by not caused by not proving the duct. If you can click, give me the one of the problems is crushed duct. You can click again, please. And by crushed duct, we're talking about a duct that's buried underground, but because of the weight of rocks or anything else that's above the duct itself, you can get ovalization, as you see here. There's really no simple solution to resolving this issue, but it's important that you not try to install a cable before proving the duct has shown that this is an obstruction that's going to cause problems. So it's not simple to resolve this ovalization. And I'll just show you how, if you can go to the next couple of clicks, how to locate obstructions, like these ovalized ducts. You could use a video camera, or you could use a mandrel, a backline, or a pulling tape to measure the distance. And this is an example in the photo on the left there. You see a mandrel that's being used to prove the duct, and you're putting it inside the dark gray in the center and rightmost drawing is the mandrel itself, and in a non-crushed duct, that mandrel should be able to pass through that without a problem. But when the duct is crushed and ovalized, your mandrel, as you're proving the duct, will show that you've got a problem there. And so you need to rectify that before you actually start pulling the duct through pulling the cable through the duct. Okay. Next slide. So, but we can look at how we can reduce the effects of friction, the mechanical forces that I talked about before. As I mentioned, the obstruction caused by ovalization or debris of an unproven duct is something that has to be taken care of before you actually start pulling cable into the duct. But even if you've got a clean duct, your cable is going to experience friction, and therefore a buildup of tension as it's being pulled through a duct. And I just want to talk a little bit about how lubricants can resolve those issues. So if you can do the first click here, one of the things that you could do to reduce friction where the cable jacket is rubbing against the duct wall is to reduce the coefficient of friction. So click, please. And by reducing the coefficient of friction, you're reducing the tension on the cable. And by reducing the tension on the cable, you're going to be able to pull that cable faster and safer. It's not going to damage the cable because you're not going to be surpassing or creating tension over the maximum tension that the cable can withstand. So another click. So we'll just show you a little way of how we measure coefficient of friction, and then how we use that coefficient of friction to measure tension or estimate tension. So another click. What we do, and Polywater is the pioneer in how to test for coefficients of friction between cable and ducts. We apply a normal force. We do have videos that you can request showing how we do these testing, but the test apparatus puts a normal force on the cable. Another click. We pull that cable against that normal force, which creates a pulling force on the right-hand side. And we use the proportion of pulling force to normal force to calculate the coefficient of friction. So click, please. So that's your coefficient of friction. So what value does knowing the coefficient of friction have? If you do another click, we'll show you that the tension that's created uses the coefficient of friction, as you see there, the middle variable in the equation within the parentheses. So the weight of the cable, the coefficient of friction, and the length that you're pulling will determine how much tension is being created on the cable as it's being pulled through a duct. Okay, so if we can reduce the coefficient of friction, we can reduce the pulling. We could reduce the pulling force required, and therefore the tension on the cable. Okay, as you one important note is that in a straight section, which we're looking at here, the coefficient of friction is acting in a linear manner. It's the amount of tension that is being created in a linear fashion. That's different than how tension is generated in a curve or a bend. So if we could go to the next slide, we could talk about sidewall pressure and end tension. Sidewall pressure, if you can click please, is the force that's exerted on the cable as it's bent around a bend inside the duct. Okay, that sidewall pressure and tension that is generated on the cable in a bend is generated in an exponential fashion. So can you click again, please? So you can see here that the tension in a bend is a function of a coefficient of friction in the exponent. So you've got your tension in, then you're multiplying that by the natural log raised to the coefficient of friction and the angle of the bend. So that's why I mentioned before that one of the issues that you might often encounter in installing cable and duct would be the inappropriate design of a duct run, either radii or too low or too small, or you've got frequent bends and things like that. And one way of taking care of those issues in that exponential buildup of friction, therefore tension, can be resolved by lubricants. Let's take a look at some examples of what I'm talking about here. So if you can go to the next slide. Here's example one. We've got a cable that's 500 meters long. We're going to be pulling from A to B, from point A to B. In order to estimate what kind of tensions we'll have at point B after pulling the cable through from point A, we need to know what the cable weight is. In this case, our example is dealing with the cable weight of 2.83 kilograms per meter. The jacket material is also important. It's PVC, and the cable diameter, outer diameter, is 45 millimeters. Then we also take a look at the duct. Duct is PVC and the diameter is 76. So we can do some calculations as to whether or not there might be a jamming probability. And that's estimated by comparing the diameter of the cable with the inner diameter of the duct. And then in this case, we're not using lubricant. But before I go into the actual calculations, I just wanted to mention that every combination of cable jacket material and duct material, and whether or not you're using a lubricant, will affect the coefficient of friction. So if your jacket was EPDM or a different type of jacket, and you're still using a PVC duct, your coefficient of friction would be different. But here we're not using lubricant, so no lubricant where you have the cable jacket and the duct, the PVC duct rubbing against each other. Without lubricant, your COF is 0.6. And if you could click again, that creates a tension of 856 kilograms force, pulling that cable from point A to point B. Again, that tension is generated in a linear fashion because this is a straight run. Let's see what happens when we introduce some bends. If you can go to the next. Okay, so we change the configuration. If you can click. So here we're introducing two 90-degree bends. The total distance of the run is approximately the same, 500 meters, just like the straight. Same cable, same duct material, but we're still not using lubricant, so our coefficient of friction in this situation is still going to be 0.60. So click, please. Here you see that the tension moves from 800 and something to 5,343 kilograms of force. And we've also introduced sidewall pressure because we've got two bends, and that is 3,475 kilograms force. So you can see that installation of this cable in duct could be problematic, especially with the sidewall pressure that this cable might experience. Every cable has its maximum tension as well as its maximum sidewall pressure, and those are data that your cable manufacturer should be able to provide you. So you never want to surpass those. In fact, you want to always maintain some type of cushion in terms of the tension and sidewall pressure that your cable will experience as it's being pulled through the duct in order to maintain a safe and reliable installation of the duct and not damage it, not create those opportunities for premature damage that we talked about earlier. So let's see what lubricants do. So we'll go to the next example 3. So we've got the same duct configuration, but this time we're going to use a lubricant. So can you click there? And with a lubricant, our coefficient moves from 0.6 to 0.11 to 0.15. We like to use a range to be safe, but Polywater has the largest database in the world of coefficients of friction for different combinations of different jackets and different duct materials. Okay, so using our software, which we call the pull planner, we can calculate what the effect of using a lubricant, in this case, a lubricant J, which is one of the lubricants that Polywater manufacture. If you can click, you can see what the reduction in both tension and sidewall pressure is. So we've gone from over 5,000 kilograms force in tension to 300, which is actually lower than what we pulled in the straight section at 500 meters without lubricant. And the sidewall pressure is also reduced. In this particular case, if we weren't using lubricant and based on these the maximum tension and sidewall pressures that the cable manufacturer provided, we would have surpassed both the tension and sidewall pressure before getting to the second bend. So it's important that you understand how tension is going to be building up and how you could use lubricant in particular situations. Let's go to the next slide. Some of you might have seen this, but I just wanted to show this video to show how all of these parts move together. This is an installation in Karnataka, HVDC installation. This was designed by Sumitomo in Japan. It's a 320 kV HVDC installation, and each run of cable in duct was over 950 meters. And the reason that they want to pull cable through duct is that they want to protect the HVDC cable. They want to pull distances, longer distances, to minimize the number of both manholes as well as splices. So you can start the video. So here it's coming off of the reel. It's going through a pusher. A pusher reduces the back tension on the cable, and it also helps to pull the cable off of the reel, of the cable reel. Back tension is important because it's basically creating more tension at the start of the cable installation inside the duct. So if you can reduce that back tension, because there's a tendency for cable to want to back out of the cable, it's creating tension that's going to cause a higher tension overall once the cable starts to go into the duct. So why don't you skip forward a little bit, Sachin? Further than that, yeah. So here, cable's coming out of the cable pusher down, being directed into the cable pit through this tube. We often call this an elephant trunk. And you see the cable coming out of the end of the tube, and it's going down this long passageway, this long tunnel, to the duct. Yeah, you can skip forward a little bit. So there you see the duct bank. You see the cable going into the duct. And what these people are doing here, they're applying lubricant onto the cable itself. They're slathering it. They're trying to cover the complete surface of the cable, because the cable inside the duct might come into contact not only at the bottom of the duct, but on the side walls or on the top of the duct. So spreading that lubricant around the total circumference of the cable is the right application. So there you see it. So let's go to the next slide. Just wanted to talk a little bit about another use of lubricants. Here they used our pull planner. This is an installation in Australia where they were pulling over 900 meters of let me see what the Taihan 33 kV cables, weighing 30 kilograms per meter. And they were pulling 3 cables through 3 separate ducts, 950 meters again. One of the constraints of this particular installation was that they had to do it very quickly. The data center where these cables were being pulled to was in a busy business sector of Sydney, Australia. So they had to pull this all three of these cables, 950 meters in one night in a period of about 6 to 8 hours. Okay, and in order to allay any concerns that they had with regards to the tension and the possibility of damage, they use our pull planner, and this is basically a summary report of the pull planner data that was provided that assured them that they would be able to make these three pulls in that span of time without surpassing either the maximum tension nor the sidewall pressure of the cable. So this was very, very heavy cable, 3 cables and very, very long distance, and they had no problem. So next click, please. One of the operations that the pull planner software allows you to do is, in order to be able to determine coefficients of friction of the materials that you're using, it allows you to back calculate coefficient of friction. So you enter all of the data in terms of the configuration of the duct itself and the weight of the cable and the different materials of both jacket and duct material, as well as the lubricant and the coefficients of friction brought by using again, this was a J lubricant. They pulled and they measured tension while they were pulling, and by measuring the ending tension, they were able to calculate back calculate the coefficient of friction. So in this case, instead of the 0.11 to 0.15 coefficient of friction, they actually got a 0.067. But we knew by using the calculations from the pull planner before they began the pull that they were safe even at 0.11. This more than half the coefficient of friction that they actually experienced. Okay, that's the benefit of using a lubricant, is that you can make safe, efficient, and non-damaging pulls of your cable into duct. We'll go to the next slide. Just very, very quickly, cable lubricant considerations. Friction reduction is the key performance indicator, but there are also some other issues like compatibility. The doctor mentioned the use of grease or petroleum jelly. There are compatibility issues with some of the cable jacket components that make those products, or could make those products incompatible with the materials that are being installed. So you need to really consider the compatibility. Polywater's lubricants are all water-based, so they're not going to have any compatibility issues with a vast majority of the cable jacket types and duct materials that they'll run into. Flame propagation application, before I mention flame propagation, application is just the ease with which you can install or apply lubricant. You saw that the people in the Karnataka situation were applying lubricant by hand. Probably 85% of people that use lubricant will do it that way, but you could also pump or use what we call a front end pack, that are plastic bags of lubricant that will deploy the lubricant deep inside of the. Then flame propagation is also a very, very important factor to consider, especially if you're talking about nuclear plants or petrochemical plants where the issue of flame propagation is important to understand. Polywater is the only manufacturer of cable pulling lubricants that offers a special specially formulated lubricant called LZ for low smoke zero halogen cable jacket materials. So those are, when considering what lubricants to use in order to make for a safe and efficient cable installation, you should take these factors into consideration. We'll go to the next slide. Why use lubricants? You can install longer distances, fewer equipment movements, therefore your installation per unit time is going to be faster because you're pulling cable as opposed to moving equipment around in shorter distance runs. Faster installation, 30 to 40% more cable installed per day. There's lower construction costs, fewer pulling pits. If you can pull longer, you can have fewer pulling pits and fewer splice pits. And so that's going to be a big savings in time and money. We've done a lot of cable installations with offshore wind turbines. And once those cables from those wind turbines come on shore, they go half a kilometer or a kilometer inland to the inverters. And if the utility or the contractor can install longer distances, they can minimize the cost of the splices, which are very, very expensive. In one case, the splice cost for these HVDC cables was over $100,000 per splice. So if you can eliminate 2 or 3 of those, you're saving a lot of money. Better grid performance with fewer splices, which is the cause of a lot of problems with the network. Fewer splices will reduce that risk, and therefore you have an overall cost reduction in the cost of the project as well as increased safety by using lubricants. You can click, I think that might be the last one. Yeah. Open it up to questions and answers. Doctor, do you want to take over at this point?
Thank you, sir. Thank you very much for such a wonderful presentation. Before I take question answer, I have to say something. I would like to say thank you to Mr. Jagdish and Mr. Sachin for making this presentation, this webinar happen. And before I take question from all the participants, I would like to invite KK Murthy Saab to say few words about the presentation. Kindly unmute and say few words. And then I'm going to invite Esapau sir also to give his view. Before I invite Esapau, kindly, I would like to invite KK Murthy sir first. Kindly unmute and say a few words.
Dr. Arora, am I audible?
Yes, please.
I welcome Charles Coles, VP Polywater USA. And on behalf of the fraternity of power engineers who are connected with cable, I congratulate him for a wonderful presentation what he has done. And the importance of different kinds of this cable laying in the trenches and cable laying in HDD, that is horizontal direct drilling, and the importance of the use of lubricants that has been very helpful. That will be helpful to the people who are in this particular business. And I once again congratulate Charles Coles Saab, and I must appreciate Dr. Arora, who had been instrumental in bringing you near us. Okay, otherwise perhaps you would have never got this opportunity. But for Dr. Arora, I
Thank you.
congratulate him. I congratulate him.
Thank you so much for your
Thank
kind
you so
comments.
much.
Now I would like to invite respected Asabao sir kindly unmute and say a few words before I start question answer session.
Good evening. Good evening, Rajesh ji. How are you?
Good evening.
First of all, I should appreciate you for your consistent and sincere efforts in bringing
Hello.
safety awareness in the interest of nation. Further, I should appreciate Mr. Charles Cooley for his mindful and important area, a specialized area, I can say, the cable pulling. Generally, cables are neglected, or a neglected lot in every practicing engineers do not adapt. Whether it's a type 2 coordination in LT installation or a cable bending radius or pulling in MU and HV, these are all the areas where people do not pay much attention. Cable is actually a trunking neck between the source and the load, as well as for the distribution center or the end use. But people, if they pay attention as advised by the presenter, it would reward them. They did not bother about much of failure and other things. I think that the participants would take much of the knowledge from the presenter, and I request all the people to abide by the measures propagated as per standards as well as by the presenter. Thank you, Rajesh and Mr. Paul.
Thank you. Thank you, sir.
Thank you.
Thank you. Before I go with the question answer, I have one small question to make. Sir, I have very simple query, basic query related to the coefficient of frequency and the sidewall pressure and tension. How to calculate that thing? Is there any formula to calculate before we?
Yes, yes. All of the tension and sidewall pressure calculations are derived from a set of equations and calculations developed in the 30s and 40s. These equations are called the Riffenberg Equations, which is the name of the guy that developed them. They're used. This is what we use in our pole planner, and that's what other companies and engineers that are designing networks and trying to estimate tensions and things like that. It's a commonly well-known set of equations that is used and approved and acknowledged by IEEE and other technical organizations around the world.
Okay, okay. And if you just talk about the slides you have shown in the slides in the example number 1, when the line was state, its length was 500 meters, you didn't mention about the sidewall pressure in that straight line case. Why?
Because sidewall pressure only when a cable is pulled around a curve.
Okay, okay.
Okay. So but in this case, the weight of the cable was the normal force applying some pressure on the cable.
The coefficient of friction was there, but there was no sidewall pressure mentioned in that example.
Right, right. And that's because it was a straight section.
Okay.
Once you go around a curve and that cable is pressed up against the inside of that curve, you're going to get that exponential increase in tension.
Now I invite all the participants. If you have any query, kindly raise your hand, and Sachinji will unmute you, and you can ask that question directly to the Charles sir.
Rajeshji, I want to make a comment with your permission.
Yes, yes, please.
The title of this webinar is Fundas of Cable Pulling. What I have learned from Mr. Charles Cole and Polywater, that how it is related to the cable installation problems. In cable installation problem, one of the factor which limits the one of the factor is cable asset management. And many distribution companies, transmission companies, they have a large cable installation network, and the weakest point is cable joints. And
True.
that is the point of unreliability. So the number of cable joints are decided by the length of the cable. One of the limiting factor of the cable length is the congested area and things like that. The second limiting factor is the size of the drum. And the third important factor which I want to highlight in India is there is no thought which is given on the, the specifications or the drum length and things like that is always a cut copy paste job which is coming from a long time. Whereas what I have seen with Polywater is they have different case studies where depending on the challenge, whatever best or maximum cable length, which will reduce the number of joints. For example, if you are pulling a cable of 80 kilometers, and if you go by the regular formula, the number of joints will be multiplied by 2. 500 meters is the cable length. But if you increase the length by 50 meters or even by 100 meters with some possibility, the number of joints can be reduced by 20%. And that can increase the asset infrastructure life and things like that.
Very
So
good advice.
Polywater
Good advice. Yeah.
Yeah, so Polywater has developed this software for the industry that is called a pull planner software. And this pull planner software is free of cost and used by many design engineers across the world. And in advance, they have theoretical tension which they want to control. So people want to control the tension or pulling force on the cable, but what is causing that pulling force is basically the coefficient of friction and sidewall pressure, and that is why the title of this webinar is Fundas of Cable.
Great.
That's what I wanted.
Great. Now I would like to invite others who anyone can raise their hand and ask the question by unmuting their self. We are ready to answer.
Hello?
Please continue. You can ask your question.
Hi, this is Abhijit here.
Good evening.
Hi, good evening. I don't have specific question regarding the cable pulling, but if Mr. Charles can guide us regarding the fault detection when there are multiple cables running out through the same duct, because we actually have one issue. We are trying to figure it out from the last 2-3 months. We tried with different techniques with different vendor, but so far no success. I mean, our cable line is of 22 kV, and along with that 11 kV, 33 kV, even cables up to 400 kVs are running. So vendors have tried with this mega instrument wherein those they inject the signal with a particular frequency, or they tried with this something.
We will be able to answer. Let me ask, sir. Can you answer on that part?
Me?
Yeah.
No, I can't answer that. I think that either you or maybe Jagdish might be able to answer that.
Okay. I will try to answer. Can you repeat the question? What is your line voltage? Is it 220 kV?
No, our line voltage is 22 kV.
And what is the problem are you facing?
So our cable right now has an issue. It has a break somewhere around. It shows 330 meters from the point of supply.
Okay.
But the issue is in that particular area there are more than 20 or 30 cables running along that cable.
Okay. I can understand your problem is to identify, pinpoint the particular problem.
Correct.
Point where that fault has happened.
Yes.
Okay. And I can suggest you there are many good kits of megas are available.
Yeah.
You can use that one that can pinpoint the fault. They are using some acoustic sensors. They move along with the route of that cable, and with that acoustic sensor, they can pinpoint the particular place where the fault has happened. That is one of the way.
Yeah, that we tried. Even
Okay.
we tried with 3-4 different vendors with 3-4 different techniques, but no luck. So that is why we are stuck.
Mr. Abhijit, where is the location and what is the company name?
I'm from Times of India. Maybe we can connect. I have given the same feedback in the feedback form also.
No issue.
What
We
is the
can talk
location?
one-to-one to
Yeah,
resolve.
that would be better. Yeah,
Yeah, I will
that
talk to
would
you.
be
Don't
better.
worry.
Yeah.
Any more questions from any participant? I think we should avail opportunity of getting the answers of queries we have in our minds related to power pulling. We have expert with us.
Hello.
Please continue.
Sir, how to identify the underground cable fall? Only distance. How to maintain, for example, 1 kilometer ST cable underground, and how to identify when which locations is cable fault? Distance.
Actually, this particular webinar is about the use of cable pulling lubricant. And we are going to have another webinar related to your query. It is very valid query, how to find the fault in the underground cable. And the expert for that will be I think we should say thank to Mr. Charles for sparing his valuable time. It is good morning time and he is having his tea or coffee because in America that it is around 5 or 6 o'clock in the morning. And with that thanks, I would like to thank you everyone who has participated and sparing their time. And we will continue such webinars to disseminate the knowledge. That is the motive of our side. That is the motive of Igniting Power Engineers. And we will collaborate with more firms who are ready to who are ready to give knowledge on new technology. And we love to talk about new technology always. With that, thank you, sir. Thank you very much. Namaskar.
Thank you very much, sir.
Thank you once again.
Okay. And sir, please conduct if cable fault regarding one another webinar.
That is going to be next target.
Okay, sir. Thank you.
Thank you,
Yeah.
everyone. Thank you, Charles, sir. Thank you very much.
Yeah, Rajesh sir, this Charles call just lost the connection. He's just reconnecting. 1 minute. Yeah, Palak,
Yes, sir.
you may announce about the feedback. Meanwhile, I will just give the details.
Yeah, thank you. Thank you everyone for participating in our today's webinar on fundas of cable pulling. I have shared the feedback form in the chat box, so I request everyone to kindly please give your valuable feedback. Thank you.
Thank you, everyone, once again. Thank you.
Thank you.
Ajay ji, thank you very much.